morning guys, so welcome again to my blog, and for today's video I will be having a summarization of chapter 5 of Ethernet. So let's start. Ethernet is the most widely used LAN technology today. It is a family of networking technologies that are defined in the IEEE 802.2 and 802.3 standard. Ethernet standard define both the layer 2 protocols and the layer 1 technologies. For the layer 2 protocols, as with all 802 IEEE standards, Ethernet relies on the two separate sublayer of the data link layer to operate. The logical link control as an MLC and the MAC sublayer. At the data link layer of the frame structure is nearly identical for all bandwidth of Ethernet. The Ethernet frame structure adds header and trailers around the layer TDU to encapsulate the message being sent. There are two styles of Ethernet framing: IEEE 802.2 Ethernet standard and the DIX Ethernet standard, which is now referred to Ethernet 2. The most significant difference between the two standards is the additional start frame delimiter SFD and the change of the type field to length of field in the 802.3. Ethernet 2 is implementation of the IEEE 802.23 standard. The Ethernet frame provides MAC address and the error checking. Layer 2 addressing provided by the Ethernet support unicast, multicast, and broadcast communication. Ethernet uses the address resolution protocol to determine the MAC address of the destination and map them against the IPv4 addressing. Each node on IPv4 networks has both MAC addresses and an IPv4 addresses. The IP addresses are used to identify the original source of final destination of the packet. Ethernet MAC addresses are used to send the packet from one Ethernet NIC to another Ethernet NIC on the same IP network. ARP is used to map and merge IPv4 addresses to MAC addresses, so the packet can be encapsulated in an Ethernet frame with the correct layer 2 addresses. ARP relies on certain types of Ethernet broadcast message and Ethernet unicast message called ARP request and ARP replies. The ARP protocol resolve IDP4 addresses to MAC addresses and maintain table of mappings. On the most Ethernet network, an end device are typically connected on a point-to-point basic layer to full duplex switch. A layer 2 LAN switch performs switching and filtering based only on the OSI data link layer 2 MAC address, and a layer 2 switch builds a MAC address table and it's used to make forwarding decisions. Layer 2 switch depend on the routers to pass data between independent IP subnetworks. The attempt to conserve bandwidth and not forward useless frames. Ethernet device drop frames that are considered to be RAM less than 64 bits or jumbo greater than 1500 bits frames. The minimum Ethernet frame is 64 bits. The maximum Ethernet frame is 1518 bits. A network technician must know the minimum and maximum frame size in order to recognize RAM and jumbo frames. Ethernet is the most common LAN protocols in the world. It operates a layer 1 and layer 2, but is not required for Ethernet communication. The OSI model is used to describe how networks operate. One connects multiple sites located in different countries. Logical link control is implemented in software and enable data link layer to communicate the upper layer of protocol suite. Logical link control is specified in the IEEE 802.2 standard, IEEE 802.3 is the standard that defines the different internet types. The Mac Media Access Control sublayer is responsible for placement and retrieval of frames on and off of the media. The Mac sublayer is also responsible for adding header and trailer to network layer protocol data unit (PDU). Any vendor selling Ethernet device must register with the IEE to user the vendor assign a unique 24-bit code, which become the first 24 bits of MAC addresses. The last 24 bits in MAC address are generated per hardware device. This helps ensure globally unique address for each Ethernet device. MAC address is composed of 6 bytes, and the 3 first bytes are used for vendor identification, and the last 3 bytes must be assigned a unique value with the same OUI. MAC addresses are implemented in hardware, and INIC needs a MAC address to communicate over the LAN, and the IEE regulates the MAC addresses. The purpose of ARP request is to find the MAC address of destination host on the Ethernet LAN. The ARP process sends a layer 2 broadcast to all devices on the Internet LAN. The frames contain the IP address of destination and the broadcast MAC address FFFF.FFF.FFF. Switch builds a MAC address to table by inspecting incoming layer 2 frames, recording the source MAC address found in the frame header. Discover and recover MAC address is then associated with the port used to receive frame. The MAC address of PC3 is not present in the MAC table of the switch because the switch does not know where to send frame, and the address to PC3 will provide the frame to all switch ports except the port of 4, which is not incoming port. When the store and forward switching method is used, the switch receives the complete frame before forwarding it on the destination. The cycling redundancy check (CRC) parts of trailer is used to determine if the frame has been modified during transit. In contrast, a cut through the switch forward this frame once the destination layer 2 address is read. Two types of cut-through switching methods are cross forward and fragment frame. Auto and DIX is a feature that is enabled on the latest Cisco switches and allow the switch to detect and use whatever type of cable attached at specific point. When a network device wants to communicate with another device on the switch on the same network, it sends a broadcast ARP request. In this case, request will contain an IP address of PC2 destination device. PC2 sends ARP reply with its MAC address. Buffering is a technique used by Ethernet switch to store frames until they can be transmitted. With port-based and buffering, frames are stored in queues that are linked to specific incoming and outgoing ports. Large number of ARP broadcast messages could cause momentary data communication delays. Network attackers could manipulate MAC address and IP address mapping as ARP message with the intent to intercept the network traffic. ARP requests and replies cause entries to be made into the ARP table, not the MAC address table. ARP table overflow are very unlikely. Manually configuring static ARP associate is a way to prevent, not facilitate, ARP poisoning and MAC address spoofing. Multiple ARP replies resulting in the switch MAC address that table containing entries that match the MAC address of the connected nodes. Associated with the relevant switch port are required for normal switch frame forwarding operation. Is not ARP cause network problem. Around supreme of fewer than 64 bits usually regenerated by collision or network interface failure. ARP spoofing or ARP poisoning is technique used by attackers to reply to an ARP request for an IP before address belonging to another device such as the port gateway. So that's all guys. Thank you for watching. I hope you get some information and you like this video. See you again in my next vlog.